Okay, this is the notes for section 4.6, translations and vectors. If you haven't done so already, make sure you pause the video and read 4.6 before continuing on. First of all, let's look at what a vector is. When we talk about a vector, it's a quantity that can be characterized by a direction and a magnitude. Okay, so when we talk about the magnitude of a vector, we're generally going to talk about it in terms of the length of that vector. However long it is, that's the magnitude of the actual vector. And when we talk about the direction of a vector, it's going to be the direction of a ray. Okay, so every vector will have a direction of a ray, and it will have a certain length that will determine that direction and that magnitude. Okay. Well, we know from our previous sections that when we looked at translations back in section 4.4, that when we describe a translation, we need two things. We need to know what is the magnitude of that translation and what is the direction of that translation. Well, those just happen to be the two same things that vectors are a quantity of. So what that means for us is that we can use vectors to do translations, which leads to the idea of what is a translation vector. And all a translation vector is a vector that gives the length and the direction of a particular translation. Okay, let's look at how we can identify translation vectors. There's a couple different ways that they can be represented and identified. The first way that we can do it is with 2 points. Okay, so if we have a point A here and a point B, the translation vector AB. Now you'll notice how when I write translation vectors, and it looks really small on here, but it's not just a line, it's a line, it's got a little harpoon on the end of it. So when I do it, it looks like this. Okay, just kind of the one side of the arrow. Okay, where we say that A is the initial point and B is the terminal point. So in other words, I start at A and I end at B. Okay, and what that vector means is that it has a distance from A to B, and the direction is from A towards B. So it's the direction is a vector, is a ray from A through B, but the distance we're going to move things is the length of AB. So it's going to move in the direction from A to B and the exact length of AB. Okay. Another way that we can write translation vectors is written as like V with that same harpoon kind of arrow over the top. Okay, or even just an italics bold V to indicate a vector as well. Okay, this vector also has a distance that's the length of the vector, so we can measure the distance from the very tip end on this side to the very tip end on this side. So this would be my initial point, this would be my terminal point. And then the direction is just given by the direction of the arrow. Okay, so those are two different ways that we can represent vectors. We're going to look at a third way here in a little bit as well on a coordinate graph. Okay, next I'd like to take a look at how we can draw translation images using a vector for translation. And I have some steps here, it's in your notes if you can kind of follow along with how I'm going to go through this. So the first thing we're going to do, if I'm going to translate a triangle ABC using the vector V, which I have a picture of down here, the first thing I need to do is I need to measure the length of that vector. So I put my ruler up to my vector, okay, and I measure that distance that it moves, and I'm coming up with about 2.7 centimeters on mine. Like I said before, mine might be different than yours because I've got mine at 150% on my screen, so it's a little bit bigger so you can see. So yours might be a little bit different than that. So that's the length of the vector. Now the second thing that the directions tell us is draw a vector parallel to V that is the same length as V with an initial vertex of A, and label the end of the vector or the terminal point as A prime. Okay, so what I'm going to do is I'm going to take my ruler and I'm going to move it so that it's over where A is. I'm going to move the same distance in that same direction. So when I'm doing this, I'm holding my ruler parallel to the vector. Okay, and you can eyeball that. It doesn't have to be perfect. Okay, and I'm going to measure down to where 2.7 is, and I'm going to plot my new point, and that new point is going to be the point A prime. Okay, so I'm going to repeat that same process with each of the other 2 points now. Okay, so I've got my ruler on B now. I'm going to measure down 2.7 centimeters, and where that point is, I'm going to plot that point on there and label that B prime. And finally, I'm going to do the same thing off of C, measure down to where 2.7 is, and plot my C point and label it C prime. Once I'm done with that, then I can go ahead and pull my ruler away, and I'm going to reconnect these points, and you'll notice that we get the same triangle. It's just been translated down the screen in this direction, exactly that distance. Okay, what I'd like you to do now is take a look at this next example. Draw the image of triangle XYZ under translation given the vector RS. So what I'd like you to do is see if you can apply the methods that we just did in that last example, and see if you can apply it to this one and actually translate that using the vector RS. And I'd like you, once you're done with that, why don't you just restart the video and I'll show you what it should look like and how we came up with that. Alright, so here's the answer to that one. Now you'll notice that I have these vectors in here, and I just drew those to kind of show you how we came up with these different points. You'll notice that each one of these vectors is parallel to the one that was given, and it's exactly the same length as the one that was given. So each of the points X, Y, and Z went exactly that distance down the page in exactly that direction. So this is what your final answer should look like there. Okay, let's take a look at number 2 here. I actually have the answer in here already, but I want to just talk through it. It says, draw and name a translation vector for the translation that occurred here. So we started with the pre-image A, B, C, D, and we got the image A prime, B prime, C prime, D prime. Okay, now to slide in that direction, and you'll notice that it is a translation, a vector can be used, and to draw in the vector, what we can do is we can take any pre-image point and make that the initial point, and take any image point and make that the terminal point, and then draw in that vector. Okay, so that would be the vector A prime, and you'll notice that I have the vector symbol over the top of that. Alright, the last way I'd like to look at translations using vectors is on a coordinate plane. And on a coordinate plane is actually probably the easiest way to translate something. It says translation figures on a coordinate plane can be described using a horizontal and vertical component. So we're going to call our horizontal component A and our vertical component B. Okay? Because of this, we can write the vector as an ordered pair. Okay? Now instead of parentheses, we use kind of these pointed parentheses to describe it. Okay? So that gives us a third way of describing a vector. We looked at it just using 2 points. We looked at it as describing it kind of as an arrow, and now we're describing it as an ordered pair. Okay? So if I'm looking at the image of any point on a coordinate plane, which we'll call XY, using a vector AB, what I'm going to do is I'm just going to add the value of A to the X coordinate and add the value of B to the Y coordinate. Alright, let's take a look at these last 2 examples here. It says, in number 3, it says M prime is the image of the point M, -2, -4, under translation by the vector -3, 6. Find the coordinates of M prime. Okay? Well, basically what we're going to do is we're going to add the vector to the point. Okay, just like we did above, adding the a coordinate to a to the x coordinate and b to the y coordinate. So when I do that would be, I'm going to put in -3 here and 6 here. Well, -2 and -3 is -5. -4 and 6 would be 2. So the coordinates of m prime would be -5, 2. Alright, let's take a look at our last example. It says suppose the translation maps t onto t prime, and we have the coordinates of those 2 points. Find the vector that describes this translation. Well, to find that vector, what I need to do is I need to solve these 2 equations. Basically, I'm saying -2 plus what number gives me 5, and 3 plus what number gives me -1. Well, the values that we would get there would be 7. If I put 7 in for A, that's going to get me to 5. And if I put -4 in for B, that's going to get me to -1. Therefore, the translation vector that I would use is 7, -4. Okay, the last thing I'd like to do is I'd like to summarize the transformations that we've done so far. We've looked at, in this chapter that is, in this chapter we've looked at 3 different transformations: reflections, rotations, and translations. Informally, we can think of a reflection as being a flip. We're flipping our figure. A rotation, we can think of that as being a turn, and a translation we can think of as being a slide. Okay? Now, how are they specifically determined? Okay? What determines what that transformation is, what's going to happen in that transformation? And in a reflection, we're using a line of reflection. In a rotation, we're using a center and a magnitude. And in a translation, we're using a vector. Okay? And then all of them can be described in terms of reflections. Obviously, a reflection is just one reflection over one line. A rotation is a composite of 2 reflections over 2 intersecting lines. And a translation is a composite of 2 reflections over parallel lines. Okay? So this is kind of just a general summary of the 3 that we've looked at so far in this chapter. We're going to look at one more actually in 4.7, and that will complete the 4 main transformations that we're looking at. Okay?